Hey Ramblers! This video covers chapter 9.1 in our textbook and deals with the concept of radicals and square roots. We'll talk about simplifying radical expressions and the operations like adding, subtracting, multiplying, dividing that you can do with radical expressions. We'll also get into solving quadratic expressions. Quadratics also often have square roots in the answer, so it's a natural tie-in. I'm going to have several problems embedded in this video, and I invite you to pause, work out the problem yourself, and I'll have the answers after that pause. It's really important that you gauge how well you know this information. If you need additional help, my free periods are 1st, 3rd, 5th, 6th, and 9th. I'm also happy to come in before school or after school, and we need you to be completely able to manipulate radicals. This stuff is going to be a big part of chapter 8, 9, 10, 11, and 12, so really the rest of the semester. I can't imagine that you'd have much of a chance at a good grade if you don't have a really fluent capability with these operations. So good luck with this video. I hope it helps. Take your time, do the problems, make sure you're getting them correct. And if you need help, come see me.
What's the square root of 49? I think most students in the class would recognize that as 7. But a fair number of you might want to say that it's positive or negative 7. And I want to cover this first because this misconception is very common, but completely erroneous. Well, maybe not completely erroneous. So let's find the root of the error. All square roots are positive. So square root of 81 equals 9. Square root of 16, well, that equals 4. So where does this positive or negative come from? The positive or negative is introduced when you're solving an equation involving a squared variable. So let's say we had x squared equals 49. Your first step would be to take the square root of both sides. And on the right side, the square root of 49 would once again be positive 7. But the square root of x squared is the absolute value of x. Now, to get rid of absolute value signs, we have to consider two cases. So either x equals 7 or opposite or negative x equals 7. That's where the negative sign comes from. So when we are just asking what is the square root of 49, well, that just equals 7. But if you're asked to solve the equation x squared equals 49, then that's where this positive or negative gets introduced. Okay, next thing I want is to make sure that you have the perfect squares memorized. Let's start there. Can you give me the perfect squares for all these numbers, 1, 2, 13, and then 15, 16, and 20? Take a minute, pause the video, and see if you can. Okay, please take a minute to memorize all of these. It's very important that you know your perfect squares because you can't really simplify radicals without knowing them. All right, how do we simplify a radical like the square root of 96? Now, many of you may have been taught to break that down into factors of 2. But I think the quicker way is to find the largest perfect squares that are factors of 96. Well, I know that the largest perfect square smaller than 96 is 81, but that doesn't go into 96. And next one down is 64, and that's not a factor of 96. Nor is 49 or 36 or 25. But I know that that 16 times 6 is equal to 96. So I can rewrite 96 as the square root of 16 times the square root of 6, which just equals 4 root 6. Now that's a perfect answer, and that's the kind of solution we'll be looking for in this class. We don't want to see that it's equal to 9.797958 ... to no matter how many decimal places you carried out. The square root of 96 in an exact answer is 4 times the square root of 6. Let's give you a couple to try. Can you tell me the square root of 98, the square root of 72, and the square root of 147? Pause the video and see if you can. Again, we want to break each of these down into the largest perfect square factors of each radicand. Okay, did you get these answers? If not, please feel free to come in and see me for some extra help. I'll be happy to help you practice this process. This process is really important because when we add and subtract radicals, we have to only add or subtract radicals that have the same radicand. So for instance, can I simplify the expression root 18 plus root 32 plus root 75 minus the root of 27? Well, you can't, because none of these have the same number under the radical, or what we call the radicand. So we have to try to simplify them. And when we do, we see that we can express 18 as the square root of 9 times the square root of 2, and the square root of 32 is 4 root 2, square root of 75 is 5 root 3, and the square root of 27 is 3 root 3. So I can combine those expressions with the same radicand to get 7 root 2 plus 2 root 3. If you have any questions with these, please ask in class or see me during a free period. Now, when we put radicals in their most simplified form, we can't have a radical in the denominator. So we can look at the square root of 7 over 2 as the square root of 7 over the square root of 2. And we're going to play a trick on the expression. I'm going to multiply by 1, but in the form of the square root of 2 divided by the square root of 2. This doesn't change the value of the expression, but it creates a perfect square in the denominator, so that we get the square root of 14 over the square root of 4, which equals square root of 14 over 2. We always multiply by whatever is in the denominator over itself. That's what gives us the perfect square in the denominator we need to take the square root of it. Let's try another one. Can you simplify the square root of 15 over 7? Take a minute, pause the video, and see if you can. Well, once again, we'll break this up into two radicals, and we'll multiply by the radical in the denominator over itself. So once again, we're only multiplying by 1. Square root of 15 times 7 is the square root of 105 over the square root of 49, which just equals the square root of 105 divided by 7. Now you should check to see if 105 has any perfect square factors, but I know that it doesn't, so this answer is simplified. Why don't you try these two? The square root of 48 over the square root of 12, but also try 3 over the square root of 17. Pause the video and try and solve them on your own. Square root of 48 over square root of 12 is most easily done by putting all of it under one radical and simplifying that. 48 divided by 12 is just square root of 4, which we all know is 2. 3 over root 17, no way to simplify that, so I have to rationalize the denominator again, which is that process of multiplying by root 17 over root 17, and we get 3 root 17 over 17. Okay, let's move on to solving quadratic expressions. But this video is getting a little bit long, so I'm going to put in a break into the video and start that under a new tutorial. When solving expressions involving a variable raised to the second power, that's called a quadratic. And there's a couple ways to do it. The first involves getting the variable isolated. So we could subtract 11 from both sides and get x squared equals 25. Then we would take the square root of both sides, and as we've seen before, this would yield the absolute value of x equals 5. So to get rid of the absolute value signs, we would consider a positive solution as well as a negative solution. And we would have x equals 5 or x equals negative 5, also written as x equals positive or negative 5. You could also do this by the factoring method. So in this case, instead of bringing the 11 over to the right side, you would bring the 36 over to the left. You get x squared minus 25 equals 0. Now I'm going to factor the binomial on the left side. Because it's a difference of squares, I get x minus 5 times x plus 5 equals 0. Now I have two numbers, x minus 5 and x plus 5, and they equal 0. So either the first number, x minus 5, equals 0, in which case x equals 5, or x plus 5 equals 0, in which case x equals negative 5. Either way, we can write it as x equals positive or negative 5, which is the same answer we got by using the square root method. Sometimes, when we're given a trinomial equal to 0, we can use the factoring method. And we'll find the factors of negative 28 that add up to 3. Well, that would be x plus 7 times x minus 4 equals 0. Now we factor the left side, giving us two factors that equal 0. So one of the factors has to be 0. So either x equals negative 7 or positive 4 are the solutions to this problem. But what happens when you can't factor? Here there are no factors of 12 that add up to negative 5. So we have to use the quadratic formula. The quadratic formula assigns a value to each of the parts of the quadratic expression. The coefficient of the quadratic is a, the coefficient of the linear term, or x, is b, and the constant is c. And all those are set equal to 0. We plug it into the quadratic formula. And x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. Plugging the actual numbers from the problem in, we see that x equals negative 5 plus or minus the square root of negative 5 squared minus 4 times a times c, all over 2 times a, which equals 5 plus or minus the square root of 25 minus 48, all over 2. This yields a negative number under the square root, which means that there are no real solutions to this problem. There are imaginary solutions, but our book will not get into those much this year. Nevertheless, I would like you to know the quadratic formula, and most of our answers will have real solutions, but if we come across one that has a negative under the square root, please be aware that that means there are no real solutions. Okay, you'll have several problems to do from the book to work on in groups. If you're having problems when you check these, it's really important that we figure out what type of problems you have trouble with, and I can give you some extra practice. Okay, thanks for listening. I hope all this helps.